Okay, so now we're going to be talking about the key ideas. So the first key idea we talked about in this chapter was units. And basically, in physics, we use units to describe what is happening around us. And we talked about the three basic units, which are time, which can be represented with an S, length, which can be represented with an M, and mass, which can be represented by kilograms. The next thing we talked about was unit consistency and conversions. So we basically went over dimensional consistency, which states an equation must have the same units. To put it simply, you can't add apples to pomegranates. You need to add apples to apples, or seconds to seconds, or meters to meters. So just basically have everything in the same units. Next, we spoke about the sum of vectors. So something to think about is when thinking about solving vectors is you have to think about the magnitude and the direction. Um, we basically discussed that to find the sum of these vectors, we can add a and b to get d, and then add c to d to get the final sum, r, or we could add b to c and get e, and then add a to e to get r. Or we could add A to B to get C, or no, A to B and C to get R directly. Or we could add lastly A to B and C in any other order and still get R. So that just shows that there's several constructions for finding the sum, the vector sum A plus B plus C. Next, we talked about vector difference. We basically explained how A minus B is equal to A plus negative B. For example, subtracting B from A is equivalent to adding negative B to A. So A plus negative B is equal to A minus B. When A and B are placed tip to tip, A minus B is the vector from the tail of A to the tail of B. Next, we talked about components of vectors. So we learned that sine theta is equal to opposite side over hypotenuse. We learned that cosine theta is equal to adjacent side over hypotenuse. And we learned that tan theta is equal to opposite side over adjacent side.